Subtraction isn't much more difficult. In a subtraction problem of complex numbers, you have to essentially distribute the subtraction sign to the second complex number. Notice the boxes here. Once you've distributed the subtraction, you simply combine your real parts, combine your imaginary parts, and you're finished. Multiplication is a little bit more cumbersome. Here's a multiplication problem. In order to multiply complex numbers, you have to follow the same basic rules of algebra, the way you would multiply polynomials. You may call this FOIL, or you may know it by some other name, but essentially, here's your first step. Let me describe where all this came from. It came from me multiplying the first two terms, 2 times 4 is 8, then multiplying the outer terms, 2 times negative 3i, then the inner terms, I times 4, and then the last terms, I times negative 3i. Now that we've performed this multiplication, I wouldn't consider this a final answer because it has some combinable terms in it. After all, aren't these two imaginary terms combinable? Couldn't this be further simplified? And likewise, aren't these two real terms also like terms? Well, they may not look like it at first. In fact, negative 3i squared may not even appear real on first glance. Let's examine negative 3i squared. Negative 3i squared, of course, means negative 3 times I squared, but let's not forget I is that strange mathematical number which, when squared, is negative 1. In other words, I can replace I squared with negative 1, thereby giving me a real answer. Notice the change made here. And now, as I was saying, I can combine my imaginary terms and I can combine my real terms. For the real terms, 8 plus 3 is 11. And for the imaginary terms, negative 6i plus 4i is negative 2i. That's how multiplication works for complex numbers.